Boom. So what's up, people? It's your boy OT and welcome to Steady Bro. Today we'll be looking at vaccines. First off, we'll try to understand what vaccines are, the Oxford vaccine, the Pfizer vaccine, and how they all relate to COVID. So vaccines. Vaccines are primers for the immune system. By primers, I mean they give immune system intel so it can better deal with the actual invading pathogen when it first comes in. You can think of a vaccine like a snitch, an informer. Check this out. So when the coronavirus outbreak began in China, right, in Wuhan, the Chinese scientists caught one coronavirus down, took him to the lab and diced him up. Their brother started singing like 6ix9ine, giving all the information. This information was in the form of genetic data. So when these Chinese dons got the genetic information from the coronavirus, they were able to sequence it. And when they sequenced it, we could now then determine this set of genetic sequence means that. It means the caspid, it means the spike on coronavirus. Now, coronavirus derived their name from the corona they have on the surface of the virus, right? These spikes that form a crown, hence the name corona. We know from previous incidences with coronavirus, from SARS, MERS, that the spike on the virus are really immunogenic, and the body does really react strong to them. So when we got the intel from the snitch, the scientists over here in the UK and the world at large were able to use this information to develop the vaccine. Now let's look at the Oxford vaccine. The Oxford vaccine is meant to work this way. A virus, an adenovirus that normally causes flu-like symptoms in chimps, Harambe's friends, and our own friends, was used, but this virus was weakened. So it could not really cause disease within the human body, but it could be used to cause an immune reaction for which the body can then prepare itself in case of an invading pathogen in the future. So this chimp virus, we took the info from the, from 6ix9ine, and we're able to identify the spike protein. So then we put that genetic sequence of the spike protein, which the body really reacts to, into the weakened virus, and then infected the normal host with it. So by infecting the normal host with it, this new virus cannot cause the disease, but it will cause a reaction within the human body so that we can mount an immune response to those spikes. So in the future, when an individual gets infected with the coronavirus, because the body has already seen this antigen, this spike protein before, and has the immune, the immune capability, be it the white cells, your B cells, your T cells, we are primed to that antigen, so we can better mount an attack and hopefully defeat the disease. In the case of the Pfizer vaccine, right? The Pfizer vaccine uses a similar modus operandi, but it's a bit different in that normally within the human body, this is how things work, right? You have a DNA, polymerase reads this DNA sequence, then transcribes it into an mRNA, right? This messenger RNA is then translated by a ribosome to form protein. In the Pfizer vaccine, we skip that first transcription. We have the mRNA already. So we have the mRNA of the spike protein, okay? So using, I don't know if this is the right word they would call it, using like a liposome, like a fat globule within which this spike protein, this corona, is within that fat globule. It's injected into a normal host, a healthy host, right? This mRNA is then translated into the spike protein and presented on the cell surfaces of the host, right? And when this occurs, the immune system, upon recognizing that this spike protein is not self, it does not belong to the host, it mounts an immune response. And by mounting this immune response, we are then equipped with the necessary arsenal to deal with the coronavirus should they affect an individual. So that is how these two vaccines actually work. Now, the question I see most people asking themselves is, given that it normally takes 10 years to make a vaccine, how come we've been able to make this vaccine in such a quick turnaround? I think there are multiple layers to try to understand this. First off, the 10 years. Those 10 years that a normal vaccine usually takes, it's not 10 years of scientists tweaking this vaccine every single day. There's a whole lot of red tapes, bureaucracy, and logistics that need to be put in place to allow first phase, second phase, and third phase of these trials to occur for it to be approved. And also, you need funds, you need money. And most of these scientists, they really spend a lot of time writing grants to try and convince institutions that their work is worthwhile and they should invest in it for them to do that. The coronavirus pandemic being the global emergency that it is, really allowed for that barrier to be overcome, because we all know it's serious. Therefore, if a scientist tells you, I'm working on something that could potentially help it, I think the institutions were more inclined to cut through certain red tapes and make sure that they put their force behind it. And additionally, money and focus was put in the right place. Because as humans, we are intelligent, but to make things happen, you need money. And when money is not around, when the funds are not around, this normally stalls operations and that. So with the money not being a problem this time around, even Big Pharma, I think, if I'm not mistaken, I think this was AstraZeneca, did make a gamble, right? At least in the case of Oxford vaccine, and they started producing it before it was approved and be used for the general public. And this is something that is not usually done. So they will normally make sure things are approved before they start producing it. But in this case, it's coronavirus. People are getting tired and fed up of wearing masks and all the regulations, which are necessary, in order to curtail the rise and kind of help the NHS in a way. It's jarring, but it's the reality. Therefore, a gamble was taken, and it seems that it's paying off. Hopefully, when they bring these vaccines out, it does what we all expect it to do. Now, in terms of the safety on a long-term basis, no one can tell you that right now. But based on the data they've collected so far, it is safe to be given to the general public at the moment. It has not been around for 20 years, so we don't know the consequence that could occur later on. But as of right now, we know it's safe, and I would urge everyone to take it. That is my personal opinion. But of course, it's a choice we all have to make on our own, yeah? So it's your boy Yodzi, and salute. If you found this video interesting, make sure you hit the subscribe button and like the video. Please, catch you around.